This experiment is the melting point depression and freezing point depression. One characteristic of the pure compound is the melting point. In this experiment, you will be making use of the melting point and the principle of freezing point depression to identify an unknown solid. There are different types of melting point apparatus in this laboratory. Each works similarly. They contain knobs that control the rate of heating and a light to illuminate the sample. Samples are placed into glass capillaries, which should fit easily into the sample chambers. Never force a glass capillary into one of these compartments. They can break easily. Before we will talk about the melting point instruments in more detail, we will show you how to prepare a sample for a melting point determination. Take your unknown and make sure that the solid is in the form of a fine powder. If it is not, grind a small quantity of sample to the proper consistently using a glass stirring rod or the flat side of a spatula and a watch glass. Use a gentle circular motion, working the solid from the edges toward the center of the watch glass. Obtain a glass capillary that is open on one end and sealed on the other. Gently push some sample into the open end of the capillary. Do not use too much sample. The height of about 2 millimeters is enough. If you use too much sample, the melting point might be lower and the range wider. If you use too less sample, it might be difficult to see and determine the melting point range correctly. Now settle the sample into the sealed end of the tube by gently tapping the tube on the desk surface. If the sample will not go down the tube, place the sample in one end of a long glass tube held upright on the lab bench. Allow the capillary to drop down the tube. This will usually force the sample down into the bottom of the capillary. You might have to drop the capillary a couple times through the long glass tube. If the crystals are packed nicely on the sealed side of the capillary tube, you're ready to take the melting point. This melting point instrument is the Melt Temp. It contains an on-off switch, a light source, an eyepiece, a sample holder, a voltage control for the heat, and a thermometer connected to a digital display of the temperature. Turn the machine and the temperature measure instrument on and place your capillary into one of the sample compartments. Again, don't use any force. For an accurate melting point, the increase of the heat should not exceed 2 degrees per minute. There are tables behind the instruments showing the proper setting of the voltage control for a certain melting point. Because you are having an unknown, you don't know the melting point of the compound. You have 1 out of 6 possible substances melting between 50 and 135 degrees Celsius. To save time, you measure your first melting point with the high setting to get an approximate melting point. Look through the eyepiece while the melting point instrument is heating your sample. Once your sample starts to melt, write down the temperature and turn off the instrument. Let it cool down about 20 degrees Celsius below the approximate melting point before you measure a second sample of your unknown. Take the first sample out of the instrument and discard it in the appropriate waste container. Never use a sample again. Place a second sample of your unknown in the melting point instrument and adjust the voltage control so that the temperature increase is 2 degrees per minute. In this case, the approximate melting point measured with the high setting was 80 degrees and the appropriate setting should be at about 3, as seen in the table behind the melting point instruments. Look through the eyepiece and note the temperature when you see the first crystals melt. The second temperature you have to write down is the temperature when the complete sample turned into a liquid. Now you have the melting point range of your unknown compound. Note that the melting point is actually not really a point. It is a melting point range. It is very important to always write down the range, rather a single melting point.